All right, well, when we started this trivia, we went back and started talking about sine, cosine, and tangent. There's also some other trig functions. So we know that sine of an angle in the unit circle is the y value. Cosine of an angle is the x value. Tangent of an angle is the y value over the x value. But all three of these have reciprocal functions as well, and those are cosecant of theta, which is the reciprocal of sine. So it's going to be 1 over the y value for the unit circle. Then we have secant theta is a reciprocal of cosine, so it's going to be 1 over x. And then cotangent theta is going to be x over y. So when we do the algebraic operations with the unit circle or pole values, we may be asked to find any of these 6 trig functions. So first example, we have a problem that says sine of 3 pi over 4 plus cosine of pi over 6. So what this is asking me is to go to my unit circle and find the y value at an angle measurement of 3 pi over 4. So if we go to 3 pi over 4, we're over in quadrant 2. This sine is the y value, so we have root 2 over 2. So that first value is going to get replaced. The whole expression is getting replaced by its value over root 2 over 2. Then we come over, we look at the cosine of pi over 6. Pi over 6 is that first angle in quadrant 1. Cosine is asking me for the x value. So the x value is going to be root 3 over 2. So if I come back over here, I'm going to have my plus sign. I have root 3 over 2. We could write this as one fraction, root 2 plus root 3, all over 2. So might as well get some practice combining fractions here. We can't combine these radicals though because they're not the same. All right, this next problem starts out as 4 times tangent of pi over 3 minus 2 times cosecant of 7 pi over 6. So tangent is going to be the y value over the x. Cosecant is the reciprocal of sine, so it's going to be 1 over the y value. So I need to multiply 4 by whatever value tangent of pi over 3 has. So I go find pi over 3 on my unit circle. The tangent requires me to take the y value divided by the x. So it's going to be root 3 over 2 all divided by 1/2. And so that replaces tangent of pi over 3. Then I have minus 2. Now I need cosecant of 7 pi over 6. So I go to my unit circle, I find 7 pi over 6. Cosecant is going to be 1 over the y value. My y value is negative 1/2. So I have 1 over negative 1/2 for cosecant. Now I need to come back and fix this. I can't leave these complex fractions, so I still have my 4 out front, but we're going to keep the top, root 3 over 2, change the multiplication, and multiply by the reciprocal. And we're going to do the same thing for the other fraction. Keep the top, change the multiplication, multiply by the reciprocal. So for the first one, you see the 2's cancel. So we have 4 times root 3 minus. Then over here we have a negative 2. But also, when I multiply the step inside here, I'm going to also get a negative 2. When I multiply both of them, I'm going to get a positive 4. This one, only one has a radical, the other doesn't. We don't have a denominator, so there's nothing more I can do to simplify that. All right, this time we're going to multiply 2 things. So we're going to go find sine of 3 pi over 4 in quadrant 2. That's going to be the y value. So I have root 2 over 2 times, and then I need cosine of 7 pi over 6, and cosine is the x value, so negative root 3 over 2. When I multiply these, when I multiply radicals, I multiply outsides times outsides, insides times insides. So I'm going to get a negative root 6 over 2 times 2 is 4. All right, Last problem, we have 6 times cosine of pi over 6 minus 2 times cotangent of 5 pi over 3. So as much as you might want to cancel these 6's, you can't, because pi over 6 is the argument for cosine. So we have to do this stuff here. It's almost like having something grouped. We have to find this value before we can multiply by 6. So we're going to do 6 times, we go find our pi over 6. Pi over 6, we want the cosine value, which is root 3 over 2, minus 2 times cotangent of 5 pi over 3. Cotangent is going to be the x value over the y value. So if I find 5 pi over 3, that's in quadrant 4. The x value is 1/2, and the y value is negative root 3 over 2. For the first expression, I can just multiply. The 2 will cancel with the 6 and leave me a 3. So I have 3 times square root of 3. Over here, I'm not going to multiply by 2 yet because I need to simplify my complex fraction. So I'm going to keep the top, change multiplication, multiply by the reciprocal. The 2's are going to cancel. So I have 3 root 3 minus, I have a negative 2 multiplied by a negative 1 in the numerator there, so it's actually going to be a plus 2. And I have a denominator of a root 3. But we can't leave a radical in the denominator, so I'm going to have to rationalize by multiplying by root 3 over root 3. So I have 3 root 3 plus 2 root 3 over 3. And because these both have a radical 3, I see that they're like terms. So I can get a common denominator by multiplying the first term by 3 over 3. Right now it's really over 1. And so when I do that, I get 9 root 3 over 3 plus 2 root 3 over 3. And I can combine these to 11 root 3 over 3. Right? So I've left some practice for you to practice with the unit circle, but you can see why it's crucial. You're not always going to have this picture of the unit circle to look at, but you're still going to be required to find these values for each of these trig functions.